Hi, the next topic is diagonalization. What is diagonalization? Let's see. If a square matrix of order n having n linearly independent eigenvectors, then a matrix P can be found such that P inverse of AP is a diagonal matrix. That is, D is equal to P inverse of AP. The formula for finding the diagonal matrix D is equal to P inverse AP, where P is called P inverse AP, where P is called a model matrix. P is called a model matrix. This P can be found out by the eigenvectors. First we find out the eigenvalues and eigenvectors. From the eigenvectors we get P. Then we diagonalize A has P formula P inverse AP, and we get a diagonal matrix. And for symmetric matrices, another formula, symmetric matrices diagonalization, we use this formula D is equal to P transpose of AP. Here P is given by P is equal to matrix x1, x2, etc. xn, where xi can be obtained from the formula capital Xi divided by norm of Xi, where capital Xi are the eigenvectors divided by norm of Xi, which is the length of the eigenvector. Okay, so this is the formula for finding Xi, and Xi is used in symmetric matrices. Okay, here P is a model matrix. This P can be find out using the formula P is equal to matrix x1, x2, etc. xn. These all are the eigenvectors obtained from the eigenvalues. Okay, now we shall do a problem. Okay, now the first question, diagonalize matrix A is equal to 1, 0, minus 1, 1, 2, 1, 2, 2, 3. This is a 3 by 3 matrix. So first of all we have to find out the eigenvalues and eigenvectors that you studied. Okay, for eigenvalues we use characteristic equation. Okay, what is the characteristic equation? Characteristic equation is, here the characteristic equation is given by lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. And what is S1? S1 is the sum of the principal diagonal elements, that is 1 plus 2 plus 3. 1 plus 2 plus 3. This is equal to 6. And S2 is equal to sum of the minors of the diagonal elements. So we have to find out the minors of these three elements and we have to take the sum. Okay, then first of all we have to find out the minor of 1. What is the minor of 1? Minor of 1 is 6 minus 2. Okay, 6 minus 2. First term 6 minus 2 plus second element is 2. We have to find out the minor of these 2. Minor of these 2 is 3 minus 2. 3 minus of minus 2. That is 3 minus of minus 2 is 3 plus 2. Plus last element is 3. So the minor of 3 is, we can omit this row and this column, and here 2 minus 0. 2 minus 0, and this is equal to 4 plus 5 plus 2. Okay, that is 11. So S2 is equal to 11. And what is S3? S3 is nothing but the determinant of A. That is equal to, determinant of A is 1 into 6 minus 2. 6 minus 2 minus the second element is 0. No need to write this element because the product will get 0. So we skip that term, and the last term is minus 1. Minus 1 into, we can omit this row and column, so we get 2 minus 4. 2 minus 4. So this is 4 minus 1 into minus 2, that is 4 plus 2, which is equal to 6. Okay, so we get S1, S2 and S3. Now we have to substitute these values in this characteristic equation. Okay, therefore we get lambda cube minus, what is S1? S1 is 6. 6 lambda square plus 11 lambda minus 6 is equal to 0. And from this characteristic equation we can find out three roots, three values for lambda, and those values are lambda is equal to 1, 2, 3. That we can find out using calculator. Okay, lambda equal to 1, 2 and 3. Now we have to find out the eigen vectors corresponding these lambda values 1, 2 and 3. Now when lambda is equal to 1, our system become, we have to subtract eigenvalue lambda from the diagonal elements. Okay, so 1 minus 1, that is 0, 0 minus 1, next element 1, 2 minus 1, that is 1, 1, and last row is 2, 2 and 3 minus 1, 3 minus 1 is 2. Okay, into x, y, z way. We have to take 3 unknowns because this is a 3 by 3 matrix. So we use x, y and z. This is equal to 0. Now you have to check whether these 3 rows are dependent or not. Look at this. The first row is 0, 0, minus 1. Here 1, 1, 2, 1, 1, 1 and last row is 2, 2, 2. So these 2 rows are dependent because this row is a constant multiple of the second row. When we multiply second row by 2, we get the third row. So these 2 rows are dependent. Therefore, we can omit one of this row. So I am omitting this row. And we have to choose first and second rows. നമുക്ക് ഇതിൽ രണ്ടിൽ ഒരെണ്ണം കളയുക. ഒരു റോ കളഞ്ഞിട്ട് മറ്റ് 2 rows ആണ് നമ്മൾ സെലക്ട് ചെയ്യുന്നത്. സോ ഐ എം ടേക്കിംഗ് ദീസ് 2 rows and I am writing the values of x, y, z. Therefore, x divided by, നമ്മൾ എന്താ ചെയ്യേണ്ടത്? എക്സിൻ്റെ കോഎഫിഷ്യൻ്റ് പോയിട്ട് ബാക്കിയുള്ളതിൻ്റെ ഡിറ്റർമിനൻ്റ് കണ്ടുപിടിക്കുന്നു. സോ 0 minus of minus 1, 0 plus 1 is equal to minus y divided by, here the coefficient of y is 0 and 1. So 0 minus minus 1. Here also 0 plus 1. This is equal to z divided by 0 minus 0. That is 0 minus 0. This is equal to t. So we get x by 1 is equal to y by minus 1 is equal to z by 0 is equal to t. Okay. ഇവിടെ നമുക്ക് x, y, z എഴുതാം. Therefore, what will be x? x is equal to x by 1 is equal to t. So x equal to 1 into t. That is x equal to t. Now y is equal to minus 1 into t. That is y is equal to minus t. And z is equal to 0 into t, that is 0. Z is equal to 0. Therefore, we get capital X is equal to t minus t, 0. Taking t outside, we get t into 1 minus 1, 0. Okay, therefore what is x1? x1 is equal to 1 minus 1, 0. This is the first vector corresponding to the value lambda equal to 1. Now we have to find out the eigen vector corresponding to lambda is equal to 2. Now when lambda is equal to 2, we get 2 minus 1 gives minus 1, 0, minus 1, 1, 2 minus 2 is 0, and next element is 1, and the last row 2, 2, 3 minus 2 is 1. This is the matrix A minus lambda I into x, y, z is equal to 0. ഇവിടെയും നമുക്ക് ഈ 3 rows ചെക്ക് ചെയ്യാം whether these rows are dependent or not. Look at this, minus 1, 0, minus 1, 1, 0, 1, 2, 2, 1. Okay, here the first and second rows are independent. ആദ്യത്തെ 2 rows ഡിപ്പെൻഡൻ്റ് ആണ് ബിക്കോസ് സെക്കൻഡ് റോ ഈസ് എ കോൺസ്റ്റൻറ്റ് മൾട്ടിപ്പിൾ ഓഫ് ദ ഫസ്റ്റ് റോ. സെക്കൻഡ് റോയെ ഒരു -1 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്താൽ ഫസ്റ്റ് റോ കിട്ടുന്നുണ്ട്. സോ ദീസ് 2 rows ആർ ഡിപ്പെൻഡൻറ്റ്. അപ്പോൾ ഒരു റോ നമുക്ക് മാറ്റി വയ്ക്കാം, ഈ റോയും നമുക്ക് സെലക്ട് ചെയ്യാം. ഐ എം ചൂസിങ് ദീസ് 2 rows. Therefore x divided by എന്താ കിട്ടുക? 0 minus 2. 0 minus 2 equal to minus y divided by 1 minus 2 equal to z divided by 2 minus 0 equal to t. That is x by minus 2 is equal to minus y by minus 1, that is y by 1 is equal to z by 2 is equal to t. Okay, therefore what will be x, y and z? X is equal to minus 2 into t, x is equal to minus 2t, y is equal to 1 into t, that is y is equal to t, and z is equal to 2t, z is equal to 2t. Okay, therefore we have capital X is equal to, what are the x here? X values minus 2t, t and 2t, and the common term is also here t. T is the common term, so taking t outside, our matrix becomes minus 2, 1, 2. So this is x, capital X equal to t into minus 2, 1, 2. Therefore, what will be x2? x2 is equal to minus 2, 1, 2. So we get x1 and then x2. Now we have to find out the eigen vector corresponding to lambda is equal to 3. Okay, when lambda is equal to 3, only the principal diagonal elements will change. In this matrix A എന്ന matrixലെ principal diagonal മാത്രമേ ചേഞ്ച് ചെയ്യുന്നുള്ളൂ. By subtracting 3 from the principal diagonal elements, we get 1 minus 3 is minus 2. Here minus 2. Here 2 minus 3 is minus 1. Here 3 minus 3 is 0. Okay. ഇനി നമുക്ക് നോക്കാം ഡിപ്പെൻഡൻ്റ് ആണോ. minus 2, 0, minus 1. 1 minus 1, 2. 2, 2, 0. No 2 rows are dependent. എല്ലാം ഇൻഡിപെൻഡൻ്റ് ആണ്, ഡിപ്പെൻഡൻ്റ് അല്ല, അല്ലേ? ഒരു കോൺസ്റ്റൻറ്റ് മൾട്ടിപ്പിൾ വരുന്നില്ല, ഡിപ്പെൻഡൻ്റ് അല്ല. സോ വി ക്യാൻ ചൂസ് എനി ഓഫ് ദ 2 rows. നിങ്ങൾക്ക് ഏതെങ്കിലും 2 rows ചൂസ് ചെയ്യാം. ഐ എം ടേക്കിംഗ് ഫസ്റ്റ് ആൻഡ് സെക്കൻഡ് റോസ്. ഓക്കെ, സോ എന്താ കിട്ടുക? എക്സ് ഡിവൈഡഡ് ബൈ ഫസ്റ്റ് 2 rows ആണ്. സോ എക്സ് ഡിവൈഡഡ് ബൈ 0 മൈനസ് 1. minus 1 into minus 1 is plus 1. So 0 minus 1. 0 minus 1 equal to minus y by minus 2 plus 1. അല്ലേ, ഇത് മൈനസ് ആണ്. സോ മൈനസ് 2 പ്ലസ് 1 equal to z by 2 minus 0. 2 minus 0. Okay. That is x by minus 1 equal to minus y by minus 2 into minus 1, that is minus 2 minus y by minus 1, that is y by 1, that is equal to z by 2 equal to t. അപ്പോൾ നമുക്ക് എക്സ് വൈ സെഡ് കാണാം. Therefore x is equal to minus 1 into t, that is minus t. Y is equal to 1 into t, that is t, and z is equal to 2 into t, that is 2t. Therefore capital X is equal to minus t, t and 2t. Okay, therefore this is equal to, t is the common factor taking outside, t into minus 1, 1, 2. We get t into minus 1, 1 and 2. From this we can write x3 as x3 is equal to minus 1, 1 and 2. So these are the 3 vectors we got from the eigen values x1, x2 and x3 we got. So eigen values, eigen vectors, half the part is over. Now we have to diagonalize the given matrix A using these eigen vectors. Okay. Now we have to write the model matrix P. What is model matrix P? Model matrix P is equal to, now the model matrix P is equal to x1, x2, x3. This is the model matrix. This is equal to, first we have to write the x1 vector, eigen vector x1 as the first column. So 1, minus 1, 0. Now second, minus 2, 1, 2, that is x2. And what is x3? Minus 1, 1 and 2. അപ്പോൾ നമ്മൾ മോഡൽ മെട്രിക്സ് എഴുതി. Now we have to, what is the formula for diagonalization? Diagonalization formula is D is equal to P inverse AP. This is the formula for finding the diagonal matrix. So we have to find out the value. We have to find out P inverse. Okay, A and P. A നമ്മുടെ കയ്യിലുണ്ട്, P നമ്മൾ കണ്ടുപിടിച്ചു. Now the only thing is P inverse. അപ്പോൾ P inverse കാണണം. P inverse കാണാനുള്ള easiest method നമ്മൾ പഠിച്ചു കഴിഞ്ഞു. So I am using that method. Now this is P. Now P inverse. എങ്ങനെ P inverse കാണുന്നത്? We are writing P, the matrix P 4 times. Okay, 1 minus 2 minus 1 minus 1 1 1 0 2 2. Again writing below this 1 minus 2 minus 1 minus 1 1 1, and the last row is 0 2 2. രണ്ട് തവണ എഴുതി. ഇനി റൈറ്റ് സൈഡിൽ രണ്ട് തവണ കൂടെ എഴുതുക. 1 minus 2 minus 1 minus 1 1 1 0 2 2 1 minus 2 minus 1 minus 1 1 1 and 0 2 2. So we write 4 times the model matrix. Now I am cutting these border elements. Border elements നമുക്ക് കട്ട് ചെയ്ത് കളയാം. Now I am writing adjoint of P. Adjoint of P ആണ് എഴുതാൻ പോകുന്നത്. നമ്മൾ ഡിറ്റർമിനൻറ്റ് 2 by 2 മെട്രിക്സിൻ്റെ ഡിറ്റർമിനൻറ്റ് കാണുന്ന പോലെയാണ് ചെയ്യുന്നത്. 1 2 into 1 2 2 minus 2, that is 0. Second one, 1 into 0 is 0. 0 minus of minus 2, 0 plus 2, that is 2. 2 is written here. First row കണ്ടുപിടിച്ച ഫസ്റ്റ് കോളം ആയിട്ടാണ് നമ്മൾ എഴുതുന്നത്. ലാസ്റ്റ് എലമെൻറ്റ് minus 1 into 2 minus 2 minus 0, that is minus 2. 0 2 minus 2. Now the next column minus 2 minus minus 4, minus 2 minus minus 4, that is minus 2 plus 4, that is 2. Again 2. Here 2 minus 0, that is 2. Last one 0 minus 2, that is minus 2. Now the last column minus 2 minus minus 1, minus 2 plus 1, that is minus 1. Next element 1 minus 1. 1 minus 1 is 0. Now the last element 1 minus 2. Minus 1 into minus 2 is plus 2. 1 minus 2, that is minus 1. So this is adjoint of P. Now we have to find out determinant of P. We have P is equal to, the model matrix P is 1 minus 1 0 minus 2 1 2 and minus 1 1 2. This is the model matrix, and we have to find out the determinant P. Determinant P is equal to 1 into 2 minus 2, that is 0, minus 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 2, that is plus 2 into minus 2 minus 0, that is minus 2, minus 1 into minus 2 plus 0, minus 2. 2 into minus 2 is minus 4. Minus 4 plus 2 here. This is equal to minus 2. We get determinant of P is equal to minus 2. Okay. Now what is P inverse? Now P inverse is equal to adjoint of P divided by determinant of P. So this is adjoint of P. Adjoint of P divided by determinant of P. So we get P inverse is equal to minus 1 by 2 into this matrix. So this is adjoint, this is P inverse. Now we have to find out D using that formula P inverse AP. Okay. Now the formula for diagonalization is D is equal to P inverse AP. This is P inverse AP. Okay. Now we have to multiply these matrices. You know all multiplication of matrix. This is equal to, I am multiplying first these two rows, then after then we multiply with this matrix. So here first row into first column gives first element, first row into second column second element, first row into third column we get third element. Okay, here 0 into 1, 0 minus 1 plus 1, that is 0. First element is 0. Next 0, here minus 2 plus 1, minus 2 plus 1 is minus 1. Last 0 minus 1 plus 3 by 2, minus 1 plus 3 by 2, minus 1 plus 3 by 2 is 1 by 2. We get 1 by 2 here. Now minus 1, minus 1, minus 2 plus 0, that is minus 2. Next 0 minus 2 plus 0, that is minus 2. Last one 1 minus 1, 1 minus 1 is 0, here also 0. Last one 1 plus 1 2 plus 1 3. Okay, 1 plus 1 plus 1 3. Here 0 plus 2, 2 plus 1, that is again 3. Here minus 1 plus 1, 0 plus 3 by 2, that is 3 by 2 into the next matrix is 1 minus 2 minus 1 minus 1 1 1 0 2 2. This is equal to 0 into 1 0 plus 1 plus 0, that is first element is 1. Next 0 minus 1 plus 1, 1 by 2 into 2 is 1. So first element is 0, second minus 1 plus 1, that is 0. Now 0 minus 1 plus 1, that is again 0. Now the next row minus 2 into 1, minus 2 into minus 1 plus 2, minus 2 plus 2 plus 0, that is again 0. Now the next element is minus 2 into minus 2 is 4, 4 minus 2, 4 minus 2 is 2, here 0, so 2. Now the next element minus 2 into minus 1, that is 2, minus 2, 2 minus 2 0 plus 0, that is 0. Now the last row 3 into 1, 3 plus 3, 3 plus 3 6, 6 plus 0. Okay. Now the last row 3 minus 3, 3 minus 3 0 plus 0, that is 0. Next element minus 2 into 3 minus 6, minus 6 plus 3, minus 3 plus 3, that is again 0. And the last element 3 into minus 1 is minus 3 plus 3, minus 3 plus 3 is 0. Here 3 by 2 into 2, that is 3. So minus 3 plus 3 plus 3, that is 3. So this is the diagonal matrix we get. Okay, this is the diagonal matrix. D is equal to 1 0 0 0 2 0 0 0 3. This is a diagonal matrix. And look at these diagonal elements. What are diagonal elements? What are the diagonal elements? 1 2 and 3. 1 2 and 3. നമുക്ക് 1 2 3 കിട്ടിയത് എവിടെയാണ്? ലാംഡ വാല്യൂസ്. ലാംഡ ഈസ് ഈക്വൽ ടു 1 2 and 3. ഇതാണ് നമ്മുടെ ലാംഡ വാല്യൂസ്. ഈ ലാംഡ വാല്യൂസ് തന്നെയായിരിക്കും ഡയഗണൽ മെട്രിക്സിൻ്റെ ഡയഗണൽ എലമെൻറ്റ്സ് ആയിട്ട് വരുന്നത്. ഓക്കെ, സോ ദിസ് ഈസ് ഡയഗണലൈസേഷൻ. ഓക്കെ, താങ്ക് യു.